corresponding and allied angles. The corresponding angles are the angles where the angle here, when you have a parallel lines, two parallel lines, and you cut it by another line, you know parallel line by the arrows. That shows that those two are parallel lines. And if you cut the angle by a line, the angle here will be correspond to that one. Likewise, the angle underneath here will be corresponding to the angle here. So if this angle is 50, then this angle here will be 50 degrees too. Therefore, this angle is corresponding to that angle. Think of it as a fraction and another fraction. Or if you like, a numerator of this fraction is equal to that numerator of this fraction. And that's how it works. And a denominator of this fraction, so think of it as the angle here. If that was 50, we know this angle here will be 130 degrees because angle on the straight line is 180 degrees. 130 plus 50 is 180 degrees. Likewise, this angle here will be 130 degrees. So, what do we see? This angle is equal to that. Again, that's the denominator is equal to the denominator here. And the numerator is equal to that numerator. So therefore, this angle are corresponding to each other. Likewise, that is corresponding to that. We can equally find this angle here because this is vertically opposite angle, and that will be vertically opposite angle. These two will be vertically opposite angle, and those two will be vertically opposite angle. The idea of F shape, you shouldn't use it, but it's just indicating that that is like an F. So you can see that's like an F, and that this angle here, which is this one, is equal to the angle there, which is that one. And the one on top here will be equal to the one on top there. So we call it F shape. But you shouldn't call it F shape. It's basically corresponding angles. On the other hand, allied angles are the angles when you've got two parallel lines like that. So that's parallel, and you cut it like that. The interior angle here, the two interior angles here must add up to 180. That's what we call allied angles. You can see if this angle is 130 and that's 50, they add up to 180 degrees. These two are called allied angles because they're inside the two parallel lines cut by the other line. So likewise, if this is 130 and this will be 50, and these two add up to 180 degrees. So that's what we call allied angles. So if this angle is 160 degrees, then this angle will be 20 degrees. And therefore, this will be 20 degrees. And if that's the case, these two will add up to 180. So these two are allied angles. So this is allied angle, that's corresponding. And this angle here will be 160 degrees because angle in a straight line add up to 180 degrees. So this will be 160 degrees. Here's an example. So the angle here will be vertically opposite. So that will be 62. But this angle here too will be 62. So that will be 62 degrees because they are corresponding angles. And the angle here will be 180 minus 62. So that will be 118 degrees. Because again, if this is 118 degrees, that will be 118 degrees. So that will be 118 degrees. So this angle is corresponding to that angle. Denominator is equal to denominator. If this is a fraction, this is a fraction, and that's a fraction. The denominator is equal to denominator. They're called corresponding angles. Numerator will be equal to numerator. They're called corresponding angles. Vertically opposite, this will be 62 as well. This one is alternate angle, that will be 62. And allied angle, 62 plus 118 must be equal to 180 degrees because that's inside a little container. The angle in a little container, the interior angle here, will be equal to 180, and they're called allied angles.